The agriculture industry relies on manual inspection to check crops condition. It could be slow, sometimes inconsistent, and facing challenges scaling across multiple growing sites. Hello, my name is Jose Soto, Technical Account Manager at AWS, and today I'm going to show you how to run AI agents at Edge using Strand agents and AWS IoT Greengrass. This is a smart agriculture system that monitors plant health with a camera, reads soil moisture from a sensor, and tracks device performance, all orchestrated by an AI agent. Let's move to today's agenda. We are going to explore AI at Edge, why Strands agents, the benefits of AWS IoT Greengrass, and last but not least, our demo. Edge AI is about running intelligence where the data is generated, on devices, sensors, and gateways, instead of sending everything to the cloud for processing. AWS provides the building blocks for this. With IoT Greengrass, you can deploy and manage software on edge devices. Amazon Bedrock gives those devices access to foundation models on demand, and Strands Agents provides the framework to build AI agents that orchestrate tools locally. Together, they let you build systems that perceive the physical world through sensors, reason about it using foundation models, and act on it in real time. Let's now talk about Strands agents. Strands is an open source SDK for building agents using just a few lines of code. It is simple to use and eliminates the need for complex agent orchestration by embracing the capabilities of state-of-the-art models. Now, why run Strands agents at Edge on this project? Three major reasons. Number one, direct hardware access. The agents tool reads GPIO pins, captures camera frames, and checks system metrics. Two, local orchestration. When a user asks, "How is my plant doing?" the orchestrator decides to call the plant health agent, which captures an image and sends it to Bedrock. That router decision happening in milliseconds at Edge. And three, Strands agent connect with all type of tools such as native Python functions, community built tools, MCP servers, or even other agents, all unified under one agent runtime. IoT Greengrass. Before we jump into the demo, let me explain what AWS IoT Greengrass is and why it becomes powerful with the Strands agents. AWS IoT Greengrass is an open source edge runtime software from AWS. You install it on a device, could be a Raspberry Pi, could be an industrial gateway, a robot, and it turns that device into a managed extension of the AWS cloud. I will enumerate four key components. 1. You package your code as component, each with a receipt that defines dependencies, install steps, and run commands. Greengrass downloads, installs, and runs them. You update a component by pushing a new version to an S3 bucket and creating a deployment. Greengrass handles the rollout. 2. Security and device development. Keeping devices, IoT data, and customer information secure and protected from threats to minimize customer issues. Securing data in transit and at rest. 3. Managing and scaling large fleets. Ability to scale to millions of devices globally with tools to simplify device management and analyze operational data. And 4. Deploying connected devices. Building, scaling, and maintaining an infrastructure to securely ingest, store, and maintain millions of devices with IoT Greengrass. Let's move now to our demo section. In this demo, we're going to be using a Raspberry Pi 5, which is running Raspberry Pi OS, and it is connected to a Raspberry Pi camera Module 3. This captures images for plant health analysis and streams live video to the dashboard, and a soil moisture sensor on GPIO pin 17. This is a simple digital sensor that reads wet or dry status. And that's it. Let me show you now our architecture diagram. This solution has two Greengrass components deployed. The first one, the Strands AI agent. This is the brain. It runs on a multi-agent system built with the Strands agents framework. There is an orchestrator agent that receives natural language query via MQTT and routes them to three specialized subagents: a device health assistant that monitors CPU, memory, and disk, a plant health assistant that captures camera images and sends them to Cloud on Amazon Bedrock for vision analysis, and a soil moisture assistant that reads the GPIO sensor and provides trends analysis. And second, the web dashboard. This is a component that is a lightweight Python web server running on port 8080. It serves as a chat interface and a live camera feed. The chat connects to the Strands agent through Greengrass IPC MQTT, and the camera streams frames directly from pCamera 2. As you can see, here is the dashboard running on the Raspberry Pi. On the left, we have the live camera feed that is streaming at 15 frames per second for this demo from the Raspberry Pi camera. And on the right, we have the chat interface. Let me ask it about the plant. Is the soil dry? The moisture sensor reads from GPIO 17 directly. No cloud call needed for this. Use a local sensor read and the agents wrap it with context and recommendation. Now let me ask about my plant's health. In this case, the agent received this query via MQTT. The orchestrator routes it to the plant health assistant, which requests a snapshot from the dashboard camera endpoint, sends it to Cloud on Bedrock for vision analysis, and returns the result. Cloud identified the plant species, assessed its health, and gave specific recommendations. Let's check for the CPU usage. For the device itself, the tool reads the system metrics locally, the agent formats the response. This is pure edge processing, and then we get a response from the device. Now let me show you a live demo MQTT. You don't need the dashboard to interact with the agent. Any MQTT client works. Here is the AWS IoT Core MQTT test client. I will subscribe to GG Monitor response topic and publish a message to GG Monitor request. In this case, I'm gonna be asking that this status of the device. This triggers the orchestrator to call all three subagents. It will check for the tool handling this information and it will give us a response. Let me walk through the code. This is where the entire Strands agent logic is in a single Python file. At the top, we import the Strands agent and tool from the Strands package, plus the Bedrock model for the foundation model connection. We configure a Bedrock client pointing to Cloud Sonnet 4.0, and this is the model that handles both orchestration and vision analysis. Then, here is where it gets interesting. Each hardware interaction is a Python function with the tool decorator. This tells the Strands agent that it can call this function. Now the multi-agent pattern. Each subagent is also a tool function that wraps the Strands agent with its own system prompt and tool sets. The orchestrator ties it all together. It is a Strands agent with a system prompt that defines routing logic. Device queries go to the device assistant, plant queries go to the plant assistant, and moisture queries go to the soil assistant. The three subagents are its tools. Finally, the MQTT handler, it connects to the Greengrass IPC, subscribes to the GG monitor request topic, and when a message arrives, passes it to the orchestrator. The response goes back to the GG monitor response, and this is the glue between MQTT and the agent. That's the entire agent. One file, tools that read hardware, subagents that are specialized, an orchestrator that routes, and an MQTT handler that connects it to the world. Strands agents on Greengrass gives you AI agents that interact with the physical world, direct sensor access, local orchestration, and cloud computing. This smart agriculture demo is one pattern. The same architecture works for industrial monitoring, building automation, robotics, or any use case where AI needs to perceive and act on the physical environment. Thanks for watching and happy cloud computing from all of us here at AWS.